Hi, I'm going to be presenting our work on experience grounds language. This is a joint presentation with Jesse Thomason and Ari Holtzman, and a joint sort of intellectual framework with a whole bunch of co-authors listed here. The basic premise of this talk is to ask the question about where we should move with NLP, and in what ways we should maybe be looking at other modalities and other notions of the world in order to improve the semantics of our linguistic representations. So, in particular, we want to start with a couple of open questions. What's the limit of text-based meaning representations? And two, even if the limit turns out to be surprisingly high, is that actually the right way to learn about the world? So is that the most data efficient way to learn meaning? And this kind of builds on an intuition that I think a lot of us have, that children seem to require some notion of embodiment or perception, and yet we don't grant that to our models. And so in practice, NLP's answer to these questions is maybe inadvertently that intelligence and NLU don't require seeing or hearing, or acting for that matter, with the maybe slight exception of an action which is a generation. So we're okay with some amount of speaking. And there's good reason that we are stuck with this paradigm. It's obviously easier for us to work with, and we've been able to scale it amazingly. So we're all familiar with these types of plots that show this increase in model capacity, increase in the amount of data that these models are consuming, and we're seeing therefore corresponding improvements on downstream tasks. There is maybe a question about diminishing returns. We're all familiar now with how at 175 billion parameters, GPT-3 is dramatically larger than our previous models. And not seeing necessarily the gains that we might have expected. And maybe there's just something in terms of the loss functions, maybe there's other things that we're going to do to be more data efficient in the text space, but our question here is maybe that's not necessarily where we want to be putting our intellectual efforts. Maybe there's a slightly different way to view the notion of sort of semantic universes. And in particular, we're going to use this term world scopes to denote this. The idea being that there's some amount of semantics and some amount of linguistic knowledge that could be extracted from small corpora, and that's where we have been indebted to, for instance, the Penn and Brown tree banks for a very long time. There's this kind of current notion that you can simply use context of arbitrary size pulled from the internet in order to improve your meaning representations, and we're really just positing that the scope of what is expressed in that universe, in that world, is smaller than if you included perception, if you included embodiment, or if you went all the way to include actual social interaction. And when you think about these growing world scopes and what they bring to the table, there's some new questions, like how does this change reporting bias? Are we still susceptible to the same kinds of issues? What kind of knowledge is actually expressed in these that wasn't present in the text representations? And I think most importantly to us is very concretely, what do we change in our models? How do we change, for instance, multimodal fusion in order to harness the benefits of these larger world scopes? And so I'm not going to do justice here to where we've come as a literature from, but I will simply say that world scope 1, we saw really great representation learning, and a lot of that came through annotation efforts. And currently what we're seeing is these models where we're not even getting close maybe to actually saturating the parameters. We're broadening from single sentence, single document to sort of as many web crawls as possible. And that's the trends that we were just talking about a second ago. And what we're going to now talk about is sort of the phenomena that are maybe not captured there. So for example, if we have an image, we can ask a question like how much knowledge is in it? This is an image of the desk at which I'm currently recording, and we could ask, maybe in text we would want every unary relationship annotated. Water bottles are clear, water bottles are metallic, mugs have words, and so forth. Maybe we want every pairwise relationship annotated. Water bottles go on desks, slippers go on the floor, or maybe we want really arbitrarily long chains of inference. Maybe it's the fact that the privacy cover is up in this photo and that you can see that there's a water bottle that's still full and a cup, and therefore the privacy cover means that I was having a meeting and the other items mean that I was eating, and so therefore we can infer that I was taking work meetings during lunch. Also true. And there's potentially a very large space of these things, but in order to get access to all of this, we not only need to be pulling knowledge from images, we need to be thinking about other places where there's linguistic signal. For example, gestures, meaningful, linguistic. Facial expressions, meaningful, linguistic, even if only expressed in emoji. Intonation and stress, we're all familiar with these, and they change the meaning of every single sentence, even if we just express them in fonts. And then next I'll hand it over to Jesse to talk about world scope 4.
Beyond a static image, Think about how much knowledge is represented in an environment that we actually live in and move around in. Like even a child playing with blocks on a tabletop, there's a lot going on. You can think about the affordances of each object that the blocks can stack, conditioned on them having the right number of prongs and right number of holes beneath. The wheels on the car can roll, they experience friction, there's some physical understanding required. We could think about using language to talk about the state transitions, how we move from what we're seeing to a future state, like that the car can host a pink block with 3 prongs on top, or we could next put on a green block with 1 prong. The car could be moved forward and backwards. The top block could be removed. And it starts to seem silly if we were going to try to enumerate all these possibilities, even in this little blocks world, because the plans and the affordances, the state transitions that we understand as humans are really mundane to write down. Even if we were going to try to write an instructional guide on WikiHow about how to use these blocks, it's unlikely we would really enumerate every possibility. And this brings us to how we talk about the physical world in general, and in particular how we talk about objects. If I were to ask a question like, is an orange more similar to a banana or a baseball? You'd kind of have to ask me under what axis we're considering similar. And this is because of the way that we can interact with these objects in the world. If we think about how they're physically similar, well, the baseball and the orange are both balls. They both roll, they can both be thrown. And if we connect language to sort of intuitive physical understanding of the world, we're likely to say that these two are more similar. And this kind of reasoning can get us a long way towards understanding metaphorical language like a distant concern, a real moonshot, thick tension, heavy emotions, in a way that we can't if we're only looking at text or even text plus pictures. But it also could mean that we want to think about affordances and plans, like that the orange and the banana can both be eaten, they're comestible. And in that sense, we could try to connect language to instruction language to how an agent should interact in the world, like that a knife can be used for slicing. And to do that, we can do work in simulation to embody an agent and have it follow instructions. And this is towards understanding how to answer questions like, should I hammer a nail with a screwdriver or a rock? A person will have no trouble saying, well, a rock is the right tool, but a machine learning system currently is likely to say screwdriver because it's more similar, because it's a tool to a hammer.
All right, let's talk about the social world. Words are interesting because they don't just describe the world, they can actually affect the world by affecting other people. For instance, if I now say, hey Jesse, would you mind pressing next on Kino? Jesse will press next on Kino, and lo and behold, my title will appear. Thanks, Jesse. Understanding social dynamics like that is necessary every time we have to simulate people in our heads, whether that's because we're talking to them and trying to think about what they're thinking and feeling, or because we're reading a book and trying to imagine the characters in it. This ability to imagine what other people are thinking and what they might be thinking about what you're thinking is called theory of mind. Let's take a look at an example. So here we have a tweet that says, annoying person. Am I annoying? Everyone, annoyed. No. Interesting. Why is everyone not telling the annoying person that they're being annoying? Because of politeness. Because we've been socialized into certain rules that we all know and can express in various ways, even though they probably weren't directly expressed to us. More like our parents were like, don't say stuff like that. Now, a language model might have a basic understanding of the kinds of things that make sense here. It might have an okay perplexity on this example. But it fundamentally doesn't have the source material to draw from to write these kinds of jokes, unless it's seen this kind of situation happen in something it's read. The same way we need to experience a social situation in order to describe it. The problem is most experiences aren't described. Now, theoretically, we could encode all of this knowledge textually or even programmatically in a simulator. However, in practice, socialization is poorly understood. We still don't know exactly what makes it tick or how it works. And there's another problem, which is socialization is highly non-static. It's highly contextual. There's a lot of history that has to do with identities, relationships, subcultures, status, and power dynamics that enter into any situation. Usually only a few of these variables are really at play, but figuring out which variables are at play is exactly where intervention in the actual social world by persisting through time and establishing relationships gives a rich learning signal that text simply can't compare to. So we've given you what we believe is the essence of each world scope, but it's time to talk about what limits them. And we can think about this from the old adage, you can't learn language from the radio or the internet. That's because if a language-only baseline is good enough for your task, you're not really keeping in mind the dynamics and the subtleties of the actual phenomena you might be studying, be it videos, images, or audio. But even there, if you have all of these complex media, and they do matter, you still can't learn language from the television or from all of these passive perceptive abilities, because you need the ability to explore. To overcome reporting bias, you need the ability to capture your own data and see what's happening even on things that people don't like to talk about, don't tend to report about. And finally, you can't learn language by yourself, because language is a fundamentally social mechanism, and how your words affect other people, this causal intervention you have the ability to learn from, is key to our understanding of language. Well, given that we just don't have a robot that we can just stuff a language model in and have it go interact with the world and experience images and video and audio and socialization, are we just stuck in World Scope 3? Absolutely not, but we need to rethink our tasks. We need to think about how to include these various phenomena from world scopes into what we're doing now. Grounding for generation, model evaluation with humans in the loop, empty systems that interact with the world, physical exploration for entailment, perception for syntactic, anaphoric, and discursive ambiguity resolution, and tests in a simulator that test things that multiple choice simply can't capture. The point is to think where signal for your task comes from, whether that's signal for learning or signal for distinguishing what the agent has learned. Our point isn't that it's theoretically impossible to learn these things from language, it's where the signal is. So the next time you sit down with a new problem, we'd like you to think about, is knowledge about task X most richly encoded in a block of text, or the rich physical and social environment we all inhabit? Thank you for listening, and let's continue the conversation.